Having understood the basics of great circle, small circle, spherical triangle, as well as the important, very important cosine formula, now we can proceed ahead to solving a basic great circle sailing question. Now, a basic, very simple great circle sailing question involves having given two different positions on the surface of Earth. Two different positions are provided to us, latitudes and longitudes, the coordinates are given, and we need to find out the great circle distance between those two positions. Now, another important thing with the great circle sailing is that when we move along a great circle track, one important characteristic of the great circle track is that the course of the ship, the heading of the ship, keeps on changing continuously. This does not happen with the simpler methods of sailing, or you can say rumbline methods of sailing, that is parallel sailing, plain sailing, or Mercator sailing. In these methods, you steer a single course from your starting position to your destination position. But in great circle sailing, as the vessel proceeds along the great circle track, the course continuously keeps on changing. So in a basic great circle question, they ask us to find out the initial course of the vessel when it starts from its initial position and the final course of the vessel when it reaches its destination. So the information which is given to us are the initial and final positions, their coordinates, that is latitude and longitude, and the items which we are required to find out is number 1, the great circle distance, and number 2, the initial and final courses. So let us see now how do we obtain these required items using the principles of spherical trigonometry. Now the first thing which we need to do is to make a rough diagram of the area. So for making this rough diagram, I will initially be using the complete Earth in my diagram. You can see the sphere being shown on the right side of the screen. This sphere represents the Earth. Later on, when we are familiar with the method, we do not need to draw the full Earth diagram. We can draw a small part which involves our initial and final position only. But for understanding, let's have the full Earth being shown. So we have the Earth here in our diagram. Let's show the equator also. You can see the equator. In our plot. Now let's plot the initial and final positions as well as the poles in this diagram. You can see the North Pole at the topmost location, and you can also see the South Pole being marked in the diagram. So let's now plot our initial and final positions. These positions are given to us in the question. Let's assume that the initial position of the ship was at this particular location. Let's name it as A. So A is our initial position. Let's mark the final position also. Let's assume that the final position of the ship or the destination is here. Let's name that final position as B. B is the final position or the destination where we want to reach. Now we want to calculate what is the great circle distance between A and B. And when we are moving along this great circle track, What is our initial course when we depart from the starting position, from position A? And what is our final course when we reach our destination position B? Now for this, let us mark the meridian of both these positions. You can see on the screen now, I have marked the meridian of my starting position A on the diagram. So this meridian is passing from the North Pole as well as from the South Pole, and this meridian also passes from my initial position A. So this is my initial position A's meridian. Now this meridian cuts the equator at a particular point. Let's name that point as C. So we have the C point on our plot now. Now let's do the same thing for our final position. You can see the meridian of the final position B plotted in the diagram. This meridian passes from the North Pole, from the South Pole, as well as from my final position B. This meridian cuts the equator at a particular point. Let's name that point as D, delta point. Now, since we want to find out the great circle distance between A and B, let's mark the great circle track from my initial position A to my destination position B. So you can see the great circle track marked in red in the diagram. The arrow shows the direction on which we will be proceeding, moving from point A to point B. So this is the great circle track between our initial and final position. Now, if we concentrate our attention on this part of the diagram, that is AC, alpha to Charlie. Now, alpha to Charlie is the arc of the meridian contained between the equator and position A. This is exactly what the definition of latitude is. The definition of latitude is the arc of the meridian contained between the equator and that particular position. So that is what AC represents. So this tells us that AC is the latitude of our initial position A. Now we also know that from the pole up to the equator, if you measure the distance from the pole up to the equator along any of the meridians, it converts or it comes out to be 90 degrees. So pole to point C is on the equator, will be total 90 degrees. So this arc, Papa to Charlie, is going to be 90 degrees. We have just now seen that AC, alpha to Charlie, is equal to the latitude of the observer, latitude of the initial position. So this tells us that the arc Papa alpha, which is marked in green now in the plot, will be equal to 90 minus latitude of A. This is also known as co-lat of A or complementary latitude of A. So in this question, the latitude and longitude of both the positions are given to us. Beta, just give me 1 minute. 1 minute. Okay, let's go ahead, beta. So calculating 90 minus latitude of A gives us the dimension of the side Papa Alpha, that is the green color side of this particular triangle PAB. Okay, now going by the same principle, you see Bravo to delta B to D is the arc of the meridian contained between the equator and position B. So again, this is the definition of the latitude. So the arc Bravo to delta represents the latitude of my final position B. I also know that pole to D, P to D will be 90 degrees. Pole to the equator along any of the meridians is always 90 degrees. So Papa to delta is 90 degrees. Bravo to delta is equal to the latitude of my final position. That tells me that Papa to Bravo, the blue color side, is going to be 90 minus latitude of B. So you can also call it as the colat of B or 90 minus latitude of B. Both mean the same thing. Now, if you pay your attention to this triangle which is formed on the earth, that is Papa, Alpha, Bravo. Now, this particular triangle is formed on the surface of earth, and all three sides of this triangle are arcs of great circles. Papa Alpha is the arc of the meridian of our initial position A, which is a great circle. Papa Bravo is again the arc of a meridian, which is the meridian of B, which is again a great circle. And the third side of this triangle, the red color side, that is Alpha Bravo A to B, is of course a great circle track. It is the arc of an great circle track. That is what we need to find out. So we have a triangle, Papa Alpha Bravo, PAB triangle, formed on the surface of a sphere, which is the earth, all three sides of which are arcs of great circles. So this tells us that this Papa Alpha Bravo triangle is a spherical triangle. Okay, so we have a spherical triangle, and in this triangle we have already identified the two items which we know. One is side Papa Alpha, which is colat of A, is known to us as the latitude is available to us in the question. The second side, Papa Bravo, which is the colat of B, again available to us as the latitude of B is given to us. Now let's try to see what all other information is available here. Let's concentrate our attention on angle Papa of this triangle. This is highlighted in the diagram now. Now angle Papa is the angle at the pole contained between meridian of A and the meridian of B. So this is the definition of D long or difference of longitude. So this is the D long between A and B. Now, as we know that the position of both these points A and B, initial and final position, is given to us, we have the longitudes of A and B known to us. Once you have the longitudes, we can easily find out what is the D long between A and B. So the D long between A and B gives us angle P of the spherical triangle PAB. So this is the third item which is known to us, that is angle Papa. And if you look carefully now, what is known to us are two sides of this particular triangle and the included angle. Thus, It satisfies the criteria for application of the cosine formula. So I'll be applying the cosine formula on triangle PAB now. Now, beta, before I go to the next slide and we apply the cosine formula, up to here, any doubt coming in your mind, please let me know.
No, sir, option.
Sir, how do we compute A and A to B is GC track?
Yeah, Krishna, please mute the mic, beta. Okay. Now, beta, A to B is a great circle track. That is what we are trying to find out. We are trying to find out the great circle distance between A to B. So AB is certainly a great circle track.
Okay, sir.
Sir, please repeat for this angle P, sir.
Okay, beta. Angle P is the angle at the pole contained between meridian of A and meridian of B. Right, beta?
Yes, sir.
That is exactly the definition of d long, difference of longitude. So this is the difference of longitude or the d long between A and B.
Okay, sir. Got it. Thank you, sir.
Okay,
So can you say again the definition of D long, please?
Okay. D long between two places is the angle at the pole contained between the meridians of those two places.
Okay, sir, thank you.
Okay, great. So, चलें बेटा, आगे चलें. Let's apply the cosine formula.
Yes, sir.
Yes, sir.
Very good. Let's go. So you can see here, this angle P is equal to the D long between A and B. So we now know that this triangle PAB is a spherical triangle and two sides and an included angle in this triangle is known to us. So we can apply the cosine formula. Let's apply the cosine formula for angle P. So cos of any angle is equal to cos of opposite side minus cos of adjacent side 1 multiplied by cos of adjacent side 2 whole divided by sine of adjacent side 1 multiplied by sine of adjacent side 2. Applied for angle P, it gives us cos of P is equal to cos of AB, AB is the opposite side, minus cos of PA, PA is the adjacent side, multiplied by cos of PB, PB is the second adjacent side, whole divided by sine of PA multiplied by sine of PB. So if you look carefully in this formula, we know what is angle P. It is the D long between A and B, both the longitudes being available to us, the D long is known. PA is known to us. We have just now seen Papa Alpha is the colat of our position A. PB is known to us. It is the colat of position B. Again, in the numerator, Papa Alpha and Papa Bravo both are known to us. So all these are marked in green, indicating that all these values are known to us. The only unknown in this equation is side AB. That's why it is marked in red. So we put these values in the formula and we can easily calculate the value of side AB. Once AB is known to us, it's a single step calculation in the scientific calculator. Once AB is known to us, we can easily find out what is the great circle distance between these two positions. AB gives you the great circle distance. Now, one very important thing to understand here is that when we apply the cosine formula, we are going to get this side AB in degrees, minutes, and seconds or decimal of a minute. Now, to calculate the distance, how do we convert this side AB into the great circle distance? Now, fortunately, 1 minute of arc of a great circle on the surface of Earth is equal to 1 nautical mile. So this side AB converted into minutes gives us the great circle distance. So from the calculator, when you apply the cosine formula, the calculator is going to give you the value of AB in degrees and minutes or decimal of a minute. We have to convert it into whole minutes. So very easy to do that. Whatever number of degrees is there in the answer, multiply it by 60. It gives you the number of minutes. Add the number of minutes along with the degrees and you get the side AB in minutes. This side AB converted into minutes gives you the great circle distance between A and B in nautical miles. Whenever you are doing any calculations on this triangle, during calculation, the side AB is always used in the degree and minute format. But when you want to write your answers for great circle distance, it is not written in degree and minute format. It is converted to minutes and then written because 1 minute is equal to 1 nautical mile. So this gives us the answer to the first part of the question. What is the great circle distance between A and B? So you see, it's very, very simple. It's a single application of the cosine formula. Okay, beta. Now you have a good look at the diagram and let me know any doubts coming in your mind.
Sir, can you explain again the conversion part, please?
Okay, beta. When you get this side AB in the calculator is going to give you the answer in degrees and minutes, correct?
Yes.
Yes, sir.
You have to convert it into minutes only. How do you do that? Multiply the degrees by 60, right? So it gets converted into minutes. To this value, add the minutes which were there in the answer and you get the minutes total from A to B. This value in minutes gives you the great circle distance in nautical miles. Did you get it, beta?
Yes, sir.
Okay, great. Any more doubt up to here, beta?
No, sir, no.
Very good, beta. Great.
Sir,
Bolo beta.
yes, sir. So this side degree and minutes, you have to multiply 60, right, sir?
That's right.
And then what we have to add, sir?
Okay, beta. Let me show you. I'm just removing the slide and opening up a whiteboard. Can I remove the slide now?
Yes.
Yes, sir, you can remove.
Okay, beta. Thanks. Just a minute, I'll remove it. Let me open up a whiteboard and show you. Okay, beta. What I meant was, let us say you calculate this great circle distance using the calculator and you get the value as 20 degree and 12 minutes. Side AB from the calculator is obtained as 20 degree 12 minutes. Now you cannot write this 2012 as your answer. The distance is represented in minutes only. So you convert the degrees into minutes. How you convert it? You multiply the degrees with 60. So when you multiply it with 60, it gives you an answer of 1200. So 20 degrees converted into minutes is 1200 minute plus the number of minutes which you had. This was 12. So you add this to the value and you get an answer of 1212 nautical miles. This is your answer for great circle distance. The great circle distance is 1212 nautical miles and not 20 degree 12 minutes.
Understood, sir.
Very good, beta. Great. So